Right.
Okay.
Hello.
Hello.
Hi. Hello.
Hello.
Just Griffin. Forgot to make tea. Hopefully Griffin tries again. I was a little late getting the meeting started. So maybe I should check. What are you guys eating?
Don Pedro's might be like the best white Mexican food there is.
Don Pedro's is good. I'm having pizza.
Well, I mean, it's Tuesday, so I'm like, well,
There we go.
I should probably have something taco related. So we got Don Pedro's.
That's fair.
Good. Yeah, good thinking. I don't know what I'm going to eat. Something. All right, now that we got everybody. I have a bunch of practices on my open math. So if you go to there and you click on the practice block, we have those derivatives. And then there's all these practices, which is stuff that we'll eventually take a test on. So the Taylor series, Newton's method, related rates, and implicit differentiation. I don't know if we did that on the last test. So you guys will want to look at some of those and make sure that you guys are good. I think most of those have answers with them. So that's like something you can do on your own. Just try working through those, make sure you're comfortable with those, and then bring questions to class based on those practice worksheets. For today, however, we're going to move a little bit more into the integrals. So at the bottom of that list of practice worksheets, there's a first practice with integration. I don't think we've done this yet, right?
No, I don't think so.
All right. So you guys can, well, I guess I can present my screen. Yeah. All right. So then if you go to the first practice with integration, you should be able to, well, let's do it over here. Yeah. Should be able to see this. Maybe I'll try to use Inkscape. We'll see how that works. Just takes a while to load. All right, so we're going to start taking some integrals. There are what are called indefinite integrals, and then there are definite integrals. So when Inkscape finally loads for me, I'll show you. But these are called definite integrals, and you can tell because there are limits of integration. Those are the numbers below and above the here we go, the integral symbol. So this one's 0 to 3. Those are called the limits of integration. You have the lower limit and the upper limit, if that makes sense. So a definite integral, the drawing will be a little bit different on this, but I can make shapes and stuff. So there's a graph or something of a function. And if I go from 0 to 3 as my limits of integration, it's this region that well, actually I can, with Inkscape, I can use the fill tool. Make it pink. So yeah, I'm getting, if I go in at 0 to 3, you can think of this as finding the area under the curve. So if you remember, we have a couple of interpretations for integrals. You could be getting the area underneath the curve of the function you're integrating. That's one thing. Or you could be getting, or you could think of it as the inverse operation of taking the derivative. So there's two things that are going to help us figure out how to do these. So if you have a definite integral, that means you have limits here. And that means you're going to calculate an actual number for the area, or typically, unless one of the limits is a variable. So in this case, we're going to be able to calculate an actual number. However, if you don't have the limits there, that's called an indefinite integral, just so you know. All right, so you got number 1. Any idea how to do that one? So remember, think of this as the area under the curve of the function that we're integrating. So we are going from 0 to 3. And our function is, well, is 4. Oh, I went light there, didn't I? So would you know the area underneath the curve for that function?
12.
Yeah. That makes sense?
Yes.
That makes sense, but
All right.
that right there
A
makes sense.
little too easy.
Exactly. See,
I don't buy it.
definitely a curveball
Some
coming
size.
somewhere.
This is like little treats leading you into the bear cave. So yeah, that's the answer for number 1.
You're joking.
No.
Wow.
Is the next one 3x?
No.
Well, okay, too hard.
So if y equals 4, you have a flat line, right?
Yeah.
What
What? 3. This equals 3.
What does y equal x look like? Go ahead and draw the graph.
Do we have to draw graphs for all of
Is it
these?
not 1? So wouldn't it be 3?
No, think of the graph. Yeah, right? Nice job, Will. So the area under the curve between 0 and 3. Can you find the area of a triangle?
1.5.
No.
How do you know where it like stops?
What's the height and what's the base of that triangle?
You have to graph it.
Yeah.
Oh, that makes sense.
$4.5.
Is that correct?
Yeah,
So it's 3 by
3 and
3,
3.
right?
Yeah.
So
So-
1/2 base times height for a
Divided by 2.
triangle.
I thought you said 1.5, and I was like, "Are you serious?" Like, who said that?
4.5.
3 times 1.5. Easy?
Yeah, so far, yes.
So that was just
Good.
4, right?
All right. Go ahead and draw this function, y equals x plus 3.
Real tired.
Try to figure out the volume. You're trying not to draw, Nate.
Was it? Yeah. Well, I don't have a notebook. I mean, I do, but like I'm upstairs, so.
And that's how you came to class. On papers. Stuff
I
in
was
your-
on time.
Oh.
I was waiting on time.
Yeah.
Eating my food, eating some Don Pedro's. I didn't think I was gonna make it, but I did.
Is it 13.5?
Is it 9?
Yeah.
So it's 9 plus the triangle on the top, which is 4.5. So 12, 13.5.
How'd you get that?
You got x plus 3.
Yes.
So at 0, it's at 3.
Mm-hmm.
Oh yeah.
And then you pretty much get the same triangle that you had before.
Mm-hmm.
But now you got a 3 by 3 underneath it.
Just
You just add them, too.
Don't listen to me, guys.
Was that good?
Boo.
How about 2x plus 3?
sheesh. Mm. 18.
You got 18?
Yeah. What did you get?
You guys think so?
Or is it 18 plus the top triangle?
No.
What's-
Yeah, 18 plus is, yeah. So it's 9 on the bottom, and then the triangle is 9, so it's 18.
Right, Papa?
Oh, I tried putting it in my head and I did not get that. But I mean, I'm not using a graph either. I don't know. I thought it was gonna be like more up.
So this had a 3 by 3 underneath it. And then it went, over 3,
6 by
up 3.
3. Which
Now
is
we're going to be going over 3, up 6. So 1/2 base times height for the triangle is 3 times 3.
Yep.
So that's 9. And then you still have that 9 below.
Mm-hmm.
But I did get 18. I don't know how I got 18, but I got 18. So
So
Are
you
you guys
did it?
good with this so far?
Is it convincing?
What about this one?
Which one?
5?
A
Yeah.
V? No clue.
Oh,
That's a
Changing the
V.
limits on me.
I can do
Absolutely.
So draw a picture, look at your interval, and figure out what the area underneath the curve is.
How do you do absolute value again?
It's a V.
It's a V.
It's been catalog. It's ABS, right?
Yeah.
But in math,
It looks like
yeah. Yeah, but oh, it's right there.
See? A V.
going
You did
from-
not have it all. Okay.
So is it not? So
So
is it,
it's 9.
yeah, so is it 9?
What are you doing this night?
You
Well, I said before Will.
is it
It is 9. Is
Yeah,
it?
'cause
Yeah.
4.5 plus 4.5.
Yeah.
what
Okay, well, I need to use the bathroom so you guys get to see a fireplace. It's like a hotel lobby.
okay.
Okay.
Oh, you did that in physics the other day. So you just take the inside? Like you would shade the upper part?
No, you would shade between the curve.
Oh, right, duh.
So like this part. Is that good? How about this one? Y equals X, but now we're from -3 to 3.
Easy.
It is 0.
It is 0. Are you using a
Well,
calculator?
what?
Do you have like an integral button?
No, it's just in my head.
Why would it be 0?
Because it's, well, -3 to 3 is slope, like, and on the left side is -3, and then right side is +3.
Yeah. So if I had that,
You like cancel them out?
They just canceled out.
yeah, this is
Okay.
below the curve.
Yeah.
This is above the curve. So yeah, this is a positive area.
Gotcha.
I guess I'll make that pink. I'm changing my scheme.
Oh no.
And look at that green. So one's positive, one's negative.
That makes sense.
So a lot of times we'll say that it's the area under the curve. It really should be called like the area between the curve and the x-axis. And
Yeah,
it
definitely.
is signed. So sometimes they'll call it the signed area underneath the curve because it can be negative when it goes below. Okay. All right, how about that one? This one's a little trickier.
Well, do it in your head.
Nah.
All right, if y equals the square root of 9 minus x squared,
Would it be 9 minus x? 3 minus x?
what's that?
Would it be 3 minus x?
No,
Whoa, it's a little circle.
it's a circle, right?
Yeah, what the heck?
It's a half circle.
Yeah, but it doesn't even touch the line.
Oh, well, the graph on your calculator might not be that good. It's
Oh,
probably low
Okay.
resolution.
yeah, it doesn't touch the line.
Yeah, it does.
It does not.
Well, I guess technically.
Yours, Griffin or Bella? Oh man,
Wait. So it would be
a dookie calculator. Ooh,
What's the radius of your circle?
3.
3.
Yeah.
Look at us, math geniuses. Oh wait, so should it go under too? Like is it
No.
full?
If you had minus square root of 9 minus x squared, it would be under.
Oh, okay.
The equation,
It would be
can
14.
you get the area then? What's that?
Is it 14?
For the area?
Yeah.
Uh,
I do
this should-
pi r squared over 2 because pi r squared is
yeah, that'd be right. Yeah. So 4.5 times pi.
yeah, it would be 14
So
something.
you'll notice that
4.5 times.
if you have y equals the square root, I'm doing this with my mouse. 9 minus x squared. Well, if I square both sides to get rid of the square root, I get this. And that's just x squared plus y squared equals 3 squared. So
What
that's
did I miss?
We
That's
got
just the
circle.
equation of a circle with radius 3.
So what did it end up being? 14 point something?
Yeah, 9 over 2 times pi. It's half.
That's a,
Wow. 9 over 2 times pi. Oh, I have that.
Okay, so that was a circle. That was just like half a circle. So, and the
So-
radius was 3. So you could still figure out the area for that. The next one
Let me write
is
that.
1 plus cosine.
4.5 pi.
I'll tell you right now, I can't do it.
Right, yeah, I know.
With my limited knowledge, I cannot do that as well.
Take a guess, Nate.
We can visualize it because cosine
It's like this.
goes like this from 0 to 90.
Sine's up, so 0.
And you've added 1, so everything's shifted up 1. So it's going to look kind of like this. And yeah, that's hard to figure out what a curved area is, right? The circle we had a formula, but not really cosine, did we?
That's 90 degrees.
What is?
So yeah, that is 90. So yeah, now we're going to go through and kind of talk about how you can actually do these symbolically. Even though the interpretation is the geometric interpretation of the area between the curve and the horizontal axis. But we'll go through these now, and then we'll come back to this one and do it.
Okay, wait. Skippy.
Doing these analytically now.
Oh, so I don't know if you explained it, but what is like the number below? You got the 3. Is that just like the range?
Yeah.
Okay.
Okay, so we're going to go back to this one.
Right now.
Yeah.
Oh yeah, right now.
Okay, I'm going to pick green. And I'll do an integral, whoops, 0 to 3 of the function 4. And then we have this little dx.
Oh, we're like redoing them?
Yeah. All right, so now we're going to think about it in the other interpretation. These are the opposite of derivatives.
Yeah.
So what do I take the derivative of? That gives me 4 as an answer.
4x. Right?
Perfect. Yeah.
Yeah.
Does that make sense?
Yeah.
So that means this will give you the value 4x. And then we sort of write, sometimes they just put a bar at the side if it's one term. If it's more than one term, they'll put like square brackets. But then they put the limits of integration here. And what that stands for, let me get rid of the stuff I put below. What that stands for is you plug in 3, and then you subtract when you plug in 0. Right?
So you just plug both of those into the 4x?
Yeah, and you take the difference between the value at the 2 endpoints.
Okay. So then you get 12.
You get 12.
Just like we got.
That's right. Is that okay?
Yeah.
Good. Let me see what the next one is.
It's like x, I think.
It's just x, right?
Yeah. X dx. And then you need like 1x. Wait, no.
Yeah, the derivative of what gives me x?
I do not know.
Well, what gives me an x in?
To the 1.
What's that?
X. To the 1.
Derivative of x is 1.
Yeah.
The derivative of what will give me an x?
The half.
There you go.
Yeah, the x to the half or whatever.
Not x to the half.
No.
How do I get to the power of x? Is this the first power of x when I take a derivative? What would I have to take the derivative
Is it
of?
half x squared?
It is half x squared. That's it.
That makes sense.
Woohoo!
Evaluate at the endpoints.
Then plug in.
So what is that? What do we need to do with the right form? Like the
thing
form on the right.
The thing on the right, if you take the derivative of it, should give you the thing that you're taking the integral of. So if I took the derivative of 1/2 x squared, I would get x.
Yeah, but are we going to see the form on the Are we going to see the form on the right, and then we have to convert it to the form on the left, or are we going to get the form on the left and convert it to the
You're gonna get
right?
the thing on the left, and you got to figure out the right. So that's
Okay.
that's how you take the integral, and then you're going to evaluate it at the endpoints and take the difference. So this will be 9 divided by 2.
So you
Minus
reverse.
0 squared divided by 2. Yeah, you do top and bottom.
No, you reverse. So instead of deriving, you reverse drive.
Antiderivative, yeah.
Yeah, antiderivative. I didn't know there's a term.
Yep.
Got it.
So there we get 4.5, right? Good.
See.
All right, so the rule for polynomials is, so let me just go through that, I guess. So if I was taking derivatives of a power rule, x to the n, oops, and I take the derivative, what's the power rule again?
Nx, n minus 1.
Yeah. Right?
Yes.
The opposite of the power rule, if you have x to the n, and you're going to take the integral, is going to be 1 over n plus 1 times x to the n plus 1. So you raise the power and then divide by the new power.
No.
Yeah, that's the inverse power rule.
Inverse power rule.
So in this one,
This is recorded, right?
yes.
Okay, good, because the notes are severely lacking.
Yeah, just some greasy down Pedro's wrapper.
Yeah, pretty much. Well, are we going to go over this in class when we
Yeah.
get there too? Or at least almost everything we did over the break, just a quick sesh or no?
Everything?
Or not,
Yeah.
Okay, not everything, but
We practiced derivatives. We didn't do a lot of new topics.
Okay.
Did we? I can't remember.
No, we just did.
I don't know. Maybe we did. I mean,
Don't you have your notes?
Yeah, we just did derivatives last time.
Wait, we were supposed to have notes?
yeah. Wait, we're supposed to take notes.
It's open note test.
Ooh,
Hey,
We're supposed to have
Do
notes.
your videos count as notes because
No.
they kind
Nate,
of.
watch the whole video during
Okay, so the inverse power rule, notice in the last one we had x to the first power. And so I raise the power to 2, and then I divide by the new power. Because if you take the derivative, that 2 comes down, and it cancels with the 1/2, and it just leaves you x. Is that okay? Okay.
We're going to 3.
Yeah, so we can do those. X
Well,
plus 3
goes.
and 2x plus 3.
So you need your 1/2. Like your derivative for the x would be the
Yeah,
1.
so the rule is that when you have a sum, you can break it into 2 separate integrals and handle each term individually. Usually, if you have a constant like 3, you'll just leave it outside of the integral because it doesn't vary, so you don't have to worry about that.
Yo.
So let's do the first term. What does that give me?
Your half x squared again.
Yeah,
Half x.
half x squared. And then my next term, I have the 3 there, but I'm going to think of this number here that's not there. You can think of it like it's a 1. And what I'm really going to think about it as is an my hand is an x to the 0.
Whoa.
And then I'll do the inverse power rule on that. So I'd raise that 0 to a 1 and divide by 1. So the integral of nothing, of just dx, is x. And we'd evaluate those from 0 to 3 to get our answer. So the zeros doesn't give me anything. When I plug in 0, I get nothing. But when I plug in 3, I get 9 over 2 plus 9. Right?
Yeah.
So what
So
is that,
12.
27 over 2?
13.
I think so.
What?
Is that right?
Is it right?
Yeah.
I had what? Oh, wait, I didn't see the over 2. Yeah.
Yeah, because 9, if you factor out a 9, you have 1 plus 1/2. So that's 3 halves. 3 halves times 9 is 27 ninths. Or 27 halves, not 27 ninths. Okay. All right, the only thing that would change if we did the other one, you'd have a 2x plus 3. So you would double this term. So this would have a 2 here, which would cancel the half. And so our answer for the next one should just be 18, 9 plus 9.
Yep.
That Discord, what the heck was that?
What?
I heard something.
Like a noise?
Yeah, it sounded kind of like Discord.
That?
No.
Gotta be Nate.
Nate, what are you doing on Discord?
I'm not. The school laptop doesn't allow Discord. That's what I'm on.
There's
Is that good? All right, with the absolute value, you would just do it like the integral of x. So I guess I'll show you. Which we just did x a couple times, so it's not that bad. You would just know that in the negative range, if you're going from negative 3 to 3 of absolute value of x dx, that's going to be twice the integral, from 0 to 3 of x dx. Because on the two sides, you're going to have a symmetrical thing. So you just double your answer for 0 to 3 for x. Does that make sense?
Yeah.
All right. We've done x plenty of times, so I'm just going to go to the next one. This one, however, I mean, we can go ahead and do it, but we're going to get x squared over 2, but our limits will be 3 and negative 3. So when we plug in 3, we'll get 9 over 2. Well, hold on. That didn't work out like I thought it would. What was my function?
It's x dx. With you.
Yeah, so if I square it, I get x squared over 2. Yeah, I get the same thing. When I plug in 3, I get 9 over 2. When I plug in negative 3, I get 9 over 2, but I got to subtract them at the endpoints. So I'm subtracting two numbers that are the same, so I get 0.
Yeah, I have no clue how you do the absolute value one of this. Like, zero clue.
You're going to just know that it's a mirror image on one side versus the other. So you're just going to do one side of it. So like 0 to 3 for x, and then just double your answer. Does that make sense?
Sure. Oh, wait. Okay. Also, question. Is the 3 to negative 3, is that the x line or the y?
The x.
Okay. Just making sure. I had to clarify.
Well, it's whatever this little dx symbol is. That's the dimension you're integrating over.
Uh-huh.
So it'd be the horizontal line.
Got it.
If you did an integral against, dy, you'd be going vertically, which we can do. We'll wait on that though. I'll wait till you're comfortable with this.
Yeah, I'll wait for the people that are doing it to finish. Talking about Bell and Will. And maybe Adrian, I can't tell.
What are we doing?
See, she's not doing it. Prove my point.
I already wrote that down. What you said earlier.
Never mind then.
This one's a little different. We're not going to do this one right now.
Skip it.
So what you're going to learn is that taking integrals is actually not that easy in a lot of cases. So like in Calc 1, you guys learn about integrals a little bit. But then you quickly realize that, you don't know how to do any of it. And then you have more calculus courses where a lot of it is you're learning new techniques of how to take integrals of tougher and tougher integrals. And that kind of hardens you to be better at this sort of thing if you were going into this sort of thing. Of course, technology can do some integrals for you. And there are integral tables where you can look up integrals, various forms of integrals, and they have the answer for what the integral would be in the giant table. So anyway, but we can do this one. We can do 8. So I'll do that. So that was the integral from 0 to pi over 2 of 1. So I'll have a separate integral for that, 1, plus 0 to pi over 2 of cosine of x dx. So my first integral, what does that give me?
X.
It is x, yeah. Good, you remember?
All right, it's locked up here. Let me tell you. Until test day where it's not.
Right. All right, so the derivative of what gives me cosine?
Sine.
There you go. So I'd evaluate those at those places. What is sine at 90 degrees?
1.
Well, yeah, 1.
Yeah.
I had to think about that for a sec.
And then minus x at 0 and sine at 0, that's just 0. So this would be your answer.
Too easy.
Pretty straightforward.
Yeah. Till test day.
All right. Well, I mean, you guys keep in mind that in your, where's calculus? You have your calculus information, your derivatives and integrals. Was this the one? Yeah.
Oh, yeah.
You know what the derivative of sine is. You know what the derivative, even cotangent is, arc sine. We haven't used that much, but we should do a little practice with that.
Next class, though.
Yeah. But here's your integrals. The integral of e to something is e to something. The integral of sine is negative cosine. The integral of cosine is sine. When you don't have the endpoints, though, when you can't plug in numbers, they all get a plus c. So whenever you do an indefinite integral and you don't have values to plug in, you always have to add the plus c. But you have these here to help you, right?
Yeah.
All right. I think that's pretty good for today. So I'll let
I
you guys
actually
go.
haven't put it. Woohoo!
A little early. I will see you Thursday, though, and then you have a long weekend. So,
Voice.
yes. All right. You guys have a good day.
Adios.
You as well.
Bye-bye.
Bye.
He didn't get him.